All right, so last time we were talking about the unit tests. And the reason, like obviously, it should be goddamn clear at this stage why testing our code is important and why unit tests are important and why the whole unit testing framework is important. And we also kind of saw look, the idea of writing these tests has made sense to us for a while. We've been writing tests since like the third week of the semester, right? But we were doing it with those assert tests. Maybe it was even the second week of the semester with the assert tests. But over time, we started to see their limitations and how our code was getting sophisticated enough that it required a little bit of extra work. So we use this unit test framework to kind of just keep everything nice. All right, so I would say, like, there's a lot of big key things that we learn this semester, right? If you were to say, like, well, if you had to say one algorithm that summarizes first year, first semester, I'd say linear search or something, right? That's a big one, right? And yet that's entirely true. But obviously, that's just one part of what we're learning. And there's a lot of big things that we're learning throughout the semester. We start with your variables, your types, your values. You write functions, ifs, Boolean expressions, loops. We started writing classes. You know, we're doing more and more. And a linear search, when you look back, all we really needed to know was like if statements and loops. Linear collection, sure, right? But obviously we've been learning more. And I would say this whole semester has been building towards this. So this is a big one, all right? What I want to make sure I'm being very clear is that like I'm not saying this is the last big topic. No. Everything from now to the end of the semester is critically important. Very much so. But this is the one that's, I could cover the subsequent topics without covering this. This is the one that we've had to like build towards that has like required the previous knowledge to get to where we are with this. So this right here, this is like what it's been about. We've been working towards this. Yeah. Advanced data structures. Yeah, I mean, this is not advanced data structures. Advanced, or is it just data structures? Oh, pardon me, data structure. You're right, 255 is advanced data structures. Data structures. It's good job connecting those dots. Yes, this leads you right into next semester. This is like what next semester is all about, plus all of the stuff that goes along with it, of course, but this is a big part of it. And let me just make sure I'm actually recording. Okay, cool. So much of this course so far, we've spent learning algorithms. But we've been making use of some data structures like lists, tuples, sets, and dictionaries. We've been using these since the very beginning, except I kind of hid it from you a little bit. Then eventually we explicitly learned about these things. And at the end of the day, like, we don't know how a list was built, and that's fine. We know how to use it, but we don't know, like, well, how does it work under the hood? We haven't answered that question, and we're not really going to answer that question today, but we'll cover that, like, next semester in more detail. We're definitely not covering tuples, sets, or dictionaries at this stage either. That's fine. But what I really want you to understand is, like, a list is not like the integers 7, right? It's different. There's more to it. And someone actually had to write the code to describe what a list is and how it operates. We never saw that code. We'll see kind of how it works soon. But we never saw that code. But somebody had to write that code. And at the end of the day, that data structure is built up. It's made up of algorithms. Everything is an algorithm. But once you start to have all of these algorithms configured the right way and put together, you have a data structure. You put it in a class. You have a bunch of methods and attributes, and it serves a simple purpose. Once you start to think about this class, all of these algorithms at a certain level of abstraction, once it encapsulates all of this stuff, we can call it like, oh, that's a list data structure. Even though under the hood, it's all just algorithms. Under the hood, a car is just all car parts. But you put them together, it's a car. And that's how, and we interface with the car, not the car parts directly. Effectively we do, but it's indirectly. So data structures. Data structures are algorithms at the end of the day, but we think of them at a level of abstraction at this like logical unit of like, well, it's a data structure. And so everything's an algorithm, but you put them together, you create a structure of data. And other algorithms are just there to do something like a linear search, where it's like very, very functional, right? And that's fine, but you put these things together and we can start to solve really complex problems. And your choice of, when you're given a problem, how many ways are there to solve a problem? You might be thinking, well, I got to do a linear search. How many ways are there to do a linear search? Well, technically infinite, but I know how I should, okay, fine. But once the problems get complex enough, you really do have a lot of flexibility in how you go about solving the problem. And you have flexibility on what data structures you use. And depending on the data structures, it might require you to use different algorithms. And if you really want to use those algorithms, well, you might have to use certain data structures. All of these, like you've got a lot of decisions that affect the other decisions you're going to ultimately have to make to go about solving these bigger problems. Okay, all of these data structures had clear functionality associated with them, and they were different, right? A list was different than a tuple, which is different from a set, which is different than a dictionary, but they're all data structures that kind of operate their own way. The most general of which is going to be like your list, but tuples had their place, sets had their place, dictionaries had their place. And they also provide some other like functional benefits. In addition to storing data, lists, well, they're easy to index your data. Some of them might have really efficient lookups. Some might be really easy to search. Some are great where you can order the data a certain way. Some are great with managing duplicates, like the sets, right? So they all have pros and cons, and they all have their own functionality associated with them. So consider the lists we've been using. We can index them. The lists have a beginning and an end. If I were to say, where's the beginning of the end? You say index 0. Where's the end? Well, however long it's the other end, right? If I say, and the elements exist in some order. Now, when I say order, I don't mean that the elements are like sorted necessarily. I just mean that if something is in index 0 and another thing is in index 1, well, one comes before the other. And they are easy to do a linear search on, that's for sure, because that's like what we've been doing. Any questions so far? All we're doing is just kind of making sure we understand where we've come from to get to where we're going. So you've been making use of these features and functionalities with lists. And you've been interfacing with them at a certain level of abstraction. But if you dig deeper and look under the hood, you're going to find a bunch of car parts. You're going to find a bunch of bits and bobs and algorithms and functions and maybe other classes that are made up of other classes that can actually implement the list. Okay, data structures are an important part of programmers' toolbox. Yeah, that's for sure. And it's like a meta tool, right? Like your if statements. Well, that's just, an if statement. That's like this thing that's built into the programming language. But a list, well, it's not really built into, like sure, Python gives you a list, but it's not built into the language in the same way that an if statement is. An if statement's an if statement. There's like a logical completeness to it in the sense that if I were to explain to someone hopefully this is already clear. Like an if statement's an if statement. An integer's an integer, right? But what's a list? Well, there's a lot of algorithms involved to make a list, right? Like it's a sophisticated tool that we're adding to our tool belt. And that tool requires all of the other simpler tools, simpler, in order to build these tools that we can use. The point I'm making is it's a much more abstract tool. If you break it down, you're going to find a bunch of functions and if statements and loops inside of the list. But we don't think about those things. We just think about the list. That's what I'm trying to say. Hopefully that's clear. So, I make a big stink about we try to interact with Python and programming languages at a certain level of abstraction, at a high enough level of abstraction where it makes our life easier and we can start to solve problems. However, it's important that you actually know what the hell is going on under the hood. In order for you, it's important that you understand these tools before you start using them. You might say, why do I need to care how a list works? I could just use the list and solve the problem. I don't need to care how the car works. I could just get in my car and drive. I don't need to care about how it works. Yeah, but you're in a course about how do I build a car. So that's what we're here to do, is you're learning how this stuff works, right? So yeah, you don't need to, but you signed up for how to build a car. You signed up for, well, especially next semester, how to build a list. Okay, so we're going to see, how do these things actually work? Sure, this whole time we've been able to interface with them at this level of abstraction, but now I'm saying let's go down. Let's see how it actually works. Any questions? Am I hitting this point too hard, or do you get the effect, or am I like, yeah, come on, get on with it? Okay. Let's start with something simple. Well, actually, what we're going to do is we're going to create a data structure. It's going to be a simple linear data structure. It's going to be similar to a list, but it's going to be a very single-purpose data structure. And the data structure, it's going to be a course. I want to make a course object. And the course object is just going to be a collection of students. So I want to make a course object to store the information about each of my students. That's what I want to do. And then what I could do is I could have a course object for each of my different courses, like who's taking math 101, who's taking 162, who's taking what, that's kind of how I want to organize my data. For my program, whatever I'm doing, I don't know, but I'm going to make a course which is going to be a collection of students. So to start, and to be clear, a student object is just going to be effectively a data class. It's a class that just stores some data. By the way, never mind. Never mind. It doesn't matter. So we're going to start with making a very simple object, a simple class called the student class. It's just going to be, what do I say here? Yeah, okay, the problem is student objects are the objects we care about, but the problem is we're going to have many students and we want a nice way to manage them all. So this is where the course class comes in, which is covered in the next section. For now, we're going to make the student class. It's a simple class to keep track of important information about the student. And we'll also implement our EQ and repr because, it's good to have those things. What does it mean for two students to be equal? And what does it mean for to print out the student? How do I want that formatted for my purposes? So here's the student class. Let's have a look. Init, well, that's my constructor. The constructor takes a first name, last name, and a student number. Great. First name, well, we set the attribute first name to whatever we got is the parameter. How do I know it's the attribute? Well, the self.firstname, that's the attribute, that's the value, that's the variable that belongs to the instance of the student that's being created. We've got a first name, last name, and student number. That's all I really care about. We could add more if we wanted, but that's all I'm really going to care about right now. Last name and student number. You'll notice the student numbers are an integer. That's entirely reasonable. Now, it's possible, by the way, just if you take a moment to think about data, you might say, okay, student number is an integer. Does it need to be, it could be a string. It could be a string of number symbols. Does it really need to be an integer? And that's a good question. Sometimes things like student numbers, there's a reason they're numbers, because you might want to perform some mathematical operations on them for like error checking and validation and whatnot. We're not going to get into that right now. But as an interesting thing, you might, if you were to think to yourself, I could make that a string. Yeah, maybe. But sometimes it actually matters if it's, the types can matter. But that's outside the scope of this course. Now, equality. Now look at this. Look at my definition of equality for this student class. Unlike the other ones, where I always compared, okay, first of all, is instance other student? Okay, great. We check, is the other thing even a student? If it's not, then they're not equal. Great. Otherwise, I'm only comparing the student numbers. I'm not comparing the first and last name. In the other examples we've seen so far, in order for our classes, our objects to be equal, I always just said compare all the attributes. If the attributes are the same, they're equal. And I could do that here. But, you know, in order for student objects to be equal, I mean, every student at St. FX must have a unique student ID, right? They must be unique, meaning a student ID is sufficient to identify an individual student. Therefore, all I really need to do is compare student IDs. Besides, you want to know how many times it drives me insane. Because there's a lot, when students like write their name on the test, and then I can't find them in the student list because they wrote they used a nickname or something. How the hell did I know that you went by like Bob, but your real name was like Wilfred? Right? Like that drives me insane. So like checking student IDs is the surefire way. Checking names can become a nightmare. Especially too when you have people where like they might have like multiple names and it's like, well, what's your first and last name? And then it becomes ambiguous for them and it becomes ambiguous for me. It becomes a nightmare. So you know what? Student ID is the safest thing ever. The first and last name, that can get tricky. Maybe they use a short form. Maybe they go by another name for whatever reason. It can get hard to compare. Student IDs, I know they're unique. We're good to go. So that's why I'm going to use that only. For your needs, you might need to say, no, I need to check all attributes. And that's fine. If you're making this program and you have something in mind and you're like, I really got to check all these things, it's the only way to guarantee that they're the same, that's fine. But for my implementation with what I have in mind, I'm pretty sure this will be sufficient. The point I'm making here is, first of all, that should be sufficient, but also what it means for objects to be equal depends entirely on what you're doing. So even though in the previous examples it was always compare the attributes, that's fine, but I don't want you to think that that's the right way to do it. No, maybe, but that's, that's how I did it before. We could do it like this too. And then our repr. You'll also notice this repr is a little different. In the previous example, the repr was always like class name parenthesis, attributes, 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 close parenthesis. That's how I did the repr before. Now I'm doing it different. And the reason before, the way I did it before, was because if I don't have something specific in mind, you go with something like that. You say class name, parenthesis, attribute, attribute, attribute. But for my purposes, no. I want to be able to like print out a class, and each student record should be formatted like last name, comma, first name, tab, student number. That's what I want. I want it to look like that. Why? Because for my needs, that's what I want. Because I have something in mind for how I want this thing to be printed out, I write it that way. If I didn't, I would go back towards something like student, open parenthesis, first name, last name, student number, or something. But because I have something in mind, I'm going with this. Like equal. What I showed you before, yeah, that works a lot of the time. But that's not the correct repr. The correct repr is what makes the most sense for what you're doing. And for what I want to do, this is my decision. I want it to look like this. Any questions about this EQ, repr, or this class at all, like in general? Yeah. The /t, that means tab. So I could type tab, but the problem is it could get weird. So you do a tab, and that's like to say like, okay, you would put their first name in, comma, space, last name, comma, space, first name, then press tab, and that's how it would be rendered. That's what that means. Do you remember what /n is? No? That's fine. Everyone will make fun of you later. It means new line. So if I did like a new line, it would be last name, comma, first name, new line, student number. I could do that if I wanted. Because otherwise, you're like, well, how would I make a string that has like a go to the next line in it in the string? You hit enter. Uh-oh, Python's like, no, that's just a new line in your editor. So /n is how you encode new lines in strings. All right, so the only thing we defined were a couple of magic methods. The main purpose of the student class is to store data. The EQ was a little different because all we care about is the student number. And repr does not follow the class name attributes format for the purpose of this program. A more specialized format is appropriate. That's what I ranted about already. By the way, whenever you have a class that is just basically storing data, sometimes we call these things like data classes, where like there's no real functionality associated with it. Sure, there's an equals and a repr, that's fine. But in some cases, you don't even need something like that. You just need a class to store some data. We call those data classes often. And in fact, in Python, there's a way to say, oh, this is a data class, and it does some extra stuff for you. We're not going to worry about that. But whenever you have something that's just storing data like that, where you've got like an attribute and a value, an attribute and a value, a key and a value, a key and a value, it's just like a dictionary, basically. Just stores some data. Yeah?
So is it more beneficial to store data in separate data classes because you can run unit tests and ensure correctness?
That would depend on a lot of things. If you have data you want grouped together, a data class is perfect, right? If you can use a built-in dictionary to just store like my dictionary, which I call a student A, it's a dictionary, and it has the key, first name, which has a value associated with it, last name, value associated with it, and so on. And you do the same thing for all your students. Effectively, you have a suite of dictionaries. That might be better for your needs, but yeah. Other questions or anything? All right, so now here we go. I'm going to warn you. It is a little cheesy the way I'm showing this to you, and it's Python's fault. Because I'm basically hijacking the list class to implement my course. I'm just building the course on top of the list. And the list has a lot of functionality built into it for us for free. Now, if this was Java, like next semester, we wouldn't be cheesing it so hard. But it is what it is right now. So a course class is going to be a collection. I'm just going to raise that a little bit. It got cloudy again. A course class is just a collection of student objects. Ultimately, student objects are going to be stored in a list, but the list is like going to be managed by the course class. And we're going to make use of a class to add specific functionality we care about. So we're going to like write proprietary functionality that's just going to make use of this list under the hood, but we're going to interface with the course. And the course is going to interface with the list, but we want to operate at like the level of interfacing with the course. And if that's unclear about what I mean by that, just hold on, you'll see where I'm going. We'll have to add the course class control, okay. We will have the course class control access to the list of students, though through methods. And so we're going to add a couple of methods to our course class. What are we going to have? Well, we're going to want to write a method to add a student to the list, remove a student from the list, to get the size of the course, the number of students that are like in the list, check if a student exists within the course, and we'll write a repr as well. We're not going to bother writing an equals for a list because that could get pretty hairy. And it can get rather complex to define equality for lists, so we're just going to skip that for now. Let's start with our constructor. So class course, well here, you know what, before we get into this, let me just go and copy and paste the student class. All right, I'm just going to get rid of this for brevity. There. So we've got our student class. It should be good to go. If you don't believe me, let's do a quick test. Make sure everything's working. A student equal, look at that. I turned on the generative AI thing. And look at that, great. Let me turn that off because it is kind of weird. Trying something last night. Someone sent me a joke and I wanted to verify. Yes, because it made, oof. It was a pretty rough joke. And you know what? I'm going to come back to this joke after we finish playing with the student class, and I want to take a moment and talk about the joke because we can actually talk about something rather sophisticated. A, B, and what should the student number be? 4876. Great. Okay, so we created a student. Let's make a B student. Obviously, I'm not testing this with the unit tests right now. They've already been tested with the unit tests, but just for our purposes, we're going to play around. And C. X, Y, and what should their student be? 6784. I like it. So let's, okay, we ran that. It wasn't mad. Let's check equality. A student equals B student. Should be true. In fact, we can even like do this. And it's still true, right? Because it doesn't matter what their first and last names are. All that matters is their student numbers match. But then, like, does C student equal B student? False, right? Because their student numbers don't match. Great. Print A student. And look at that. Print B student. C. There we go, cool. So we're printing out the student. So any questions? Is anyone concerned about the correctness of this at this stage? Or we're pretty happy. It was a simple little class just storing some data with the magic methods for equalities and whatnot. Now, for right now, I'm going to pause the recording to take a moment. All right, and we're back. Okay, so student class, it seems to be working. We're all good to go. Now, course class. The course will be a collection of students. All right, I already said this. We're going to have a method to add a student, remove a student, get the size, and check if a given student exists within the course, and then repr. When I say check if a given student exists in the course, does anything come to mind? Well, when we get there, maybe something will. All right, well, let's start with writing the constructor. What time is it, by the way? 14:36. Damn it. All right, well, here's the constructor. What do we have? Well, the constructor is only going to take a string that is going to be the name of the course. So a course will know what it is. It might be like CSCI 161, right? Or I guess it says course name. That's a course code. Course name would be like, what's this course called? I don't even know. Intro to Computer Science. Perfect. Intro to Computer Science makes sense. So it's got a course name. And now here's something that you may have never seen before, but is entirely reasonable and in fact really goddamn common. You just haven't seen it before. How many attributes are there in this course class? Pay attention. I want everyone to make sure they see this. How many attributes are there in the course class? 2. But there's only one parameter. But think about it. When I create a course, we're going to want some container to store the students. We're going to use a list. So what do we put in that list when we start with a new course? It's an empty course. Well, an empty list. So whenever we create a course, it starts empty, right? So we didn't need another parameter to assign to the students. We just create the list of students, and how many students are in the course at this point? None. So it's an empty list. Do you notice anything else about what we see here? Anything a little peculiar? It's subtle, but it's there. The underscore. The students starts with an underscore. What's going on there? Well, first, let me go here and do this, okay? Let's do it without an underscore. And I say, okay, I'm going to make a new course. What should the name of the course be? Try again. Let's just do this, okay? Math, get out of here. There, okay, we ran it. We're good to go. Now, if I say my course dot, and look, okay, we've got course name and students. If I were to say course name, it would give me back the course name. If I say students, it's going to give me back, well, the empty list. And if you don't believe me, well, let's just, okay, there, yeah, there it is. And students, there it is. Now, I want to make very clear about something. See this little pop-up window here? This is showing you like the autocomplete options. Now, I'm going to warn you, this is not a Python thing. This is a Colab thing. This is the IDE, this development environment, has that built in. Now, if we were using something like PyCharm, another Python IDE, it would do this too, don't get me wrong, but that's not a Python thing. This is just what the development environment gives you on top of Python, all right? And the way this development environment is acting is it's following some conventions and whatnot. And there is a very special convention when dealing with classes. If I start something with an underscore, I'm going to rerun this starting with an underscore, and I hit run, oops, dot, you will notice the attribute that starts with the underscore is not there anymore. I can do the same thing with course name. And if I go down here, dot, it's like it's not there anymore because it starts with an underscore. Now, I want to be very clear. It's still there. I can still call it. But the development environment in that little pop-up window, it just kind of like hid it from me. And that's intentional because whenever, just go back to normal. Oh. First of all, it's a convention. This is not something built into the language. But if this was 162, there is something built into the language to allow us to force this upon the like our code. But it's just a convention here. In the same way that like all uppercase means constant. Yeah, you can still change the value, but don't. Here, the underscore means, okay, this is an attribute that is important for the operation and the existence of the course class. However, I don't want anybody outside of the course class to touch it. It means this attribute exists, but cannot be directly accessed from outside the class. I can directly access course name because that's fine. What's the course name? Give me the course name. Great. But I don't want direct access to students. I don't want to ever be able to go in and mess with the students. The course class is the gatekeeper to that students list. Anything that gets added or removed or anything to that list has to go through the course class and how I'm allowed to interact with it. I'm never allowed direct interaction with that list. This concept is one that new programmers tend to struggle with for a little bit until it clicks. And we're going to pick up here tomorrow.